This is a follow-up lesson to a lesson we've done previously on sketching circular functions with the horizontal translation or phase shift. Right. So if you haven't already watched that video yet, I'd highly recommend you to go and have a look at example 1 first before you can come on to this video, where we're going to try and sketch the function y equals 2 times 2 brackets x minus pi on 3 take away square root 3 for the domain x falling between 0 and 2 pi, both inclusive. Right, they're obviously asking us to clearly indicate axis-intercepts, meaning they want us to find the x and y intercept. So like we did with the previous example, I'm going to start off with some basics. Right, amplitude in this case, sorry about that. Right, amplitude in this case is equal to 2. Right, period of this function is 2 pi on 2, which is equal to pi. Right, we can see we've got a horizontal shift of a positive pi on 3, so which means we're going to move to the right by that many units. We've got a vertical translation of minus square root 3, right? So obviously we're going to move down by square root 3 units, right? Now, like we did in the previous video, we're going to start with the mean value. So obviously because we're moving down by square root 3 square root 3 units, right? Our mean value is going to sit as minus square root 3. Right, our max is going to sit at minus square root 3 plus the amplitude, which in this case is 2. And our minimum value is going to sit at minus square root 3 take away 2. And again, like we did with the previous example, we're going to work out the approximate values. This is going to be minus 1.73. Then we got minus 1.73 plus 2, giving us a positive 0.27, and a minimum value of minus 3.73, right? Obviously, again, we have a value one above the x-axis and one below the y-axis, which means we are definitely going to have some x intercepts in this particular scenario, right? So let's quickly move on to finding the x and y intercepts to start with. Right, to find my x-intercept, I'm going to make y equals 0. So we're going to have 0 equals 2 times sine 2 brackets x minus pi on 3 take away the square root 3. Right, making sine the subject, so we're going to have sine of x 2 times x minus pi on 3. Right, I'm just going to make sure I select the correct pen. So is equal to the square root 3 or 2, right? This time the value for sine is a positive value, so again we're going to look into the 4 quadrants, CAST, right, telling me that the sine is positive in the first and the second quadrant, right? So looking at the value for theta, when it's equal to square root 3 on 2, is going to be at 60 degrees or pi on 3 radians, right? Second quadrant, pi minus theta, right? Pi minus theta is going to leave me with 2 pi on 3, right? Now let's go back to solving for x. So we're going to have 2 times x minus pi on 3 is equal to pi on 3 for the first quadrant. And for the second quadrant, 2 times x minus pi on 3 is equal to 2 pi on 3, right? Now we're going to solve for x in both the cases, dividing both sides by 2. X minus pi on 3 is equal to pi on 6. X is going to be equal to pi on 6 plus pi on 3, right, making the denominators the same, leaving us with 3 pi on 6, or in a simplified version, just pi on 2, right, giving us my very first x-intercept. Right, second part of the question, so x minus pi on 3 equals 2 pi on 6, or just basically pi on 3. So adding pi on 3 to both sides, giving us my second x-intercept as 2 pi on 3. Right, obviously in this particular question we are sketching between 0 to 2 pi, right? And then just going back to this step here, we've seen that the period of the graph is equal to pi, which means we'll be able to fit 2 cycles in the domain we're trying to sketch. So obviously what that means by that is obviously we're going to have 2 further x-intercepts in this scenario, right? Like we did in the previous case. In this case, because we're moving in the right hand direction for finding the next x-intercepts, we're going to add a period to each of the x-intercepts we already found out. So pi on 2 plus pi, giving us the next x-intercept to be 3 pi on 2, and then one final one, x is equal to 2 pi on 3 plus pi, giving us the final x-intercept as 5 pi on 3, right? So obviously we've worked out all the 4 x-intercepts for this question, right? Now, like we did in the previous example, we're also going to be worried about the endpoints for this question. So again, because we can fit 2 complete cycles, the y-coordinate of the endpoints are going to be the same. So I'm going to try and find the first one, and then I'm going to use the value for the second one. So when I find the value for y when x is equal to 0, so let's go ahead and work that out. So 2 times sine 2 brackets minus pi on 3. So we're going to substitute x as 0, leaving us with minus pi on 3. Take away the square root of 3, right? Now, so which leaves us with 2 times sine of minus 2 pi on 3. Right, talking about negative angles, sine of minus theta is same as writing minus of sine theta. Right, so which means we can rewrite this as minus 2 times sine 2 pi on 3. Right, 2 pi on 3. 2 pi on 3 is an angle in the second quadrant. Right, if that's an angle in the second quadrant, it relates to the first quadrant with the value of theta being pi on 3. Right, so sine of pi on 3 is equal to the square root of 3 over 2. Right, leaving us with minus 2 times the square root of 3 on 2 minus root 3. The 2's cancel out. Right, leaving us with minus 2 square root 3 as the y-coordinate of the endpoint. Right, so that means I can conclude my endpoints are going to have coordinates 0, minus 2 square root 3, and 2 pi minus 2 times the square root of 3. And again, approximate value, 1.73 times 2, so approximate value is going to be 3.46, or minus 3.46, right? I'm just going to fix that. Right, minus 3.46 is going to be the approximate value of the y-coordinate of the endpoint. Right, now that we've located all the things, we're going to go jump straight into the graph. Right, now before I do that, again, if I look at my x-intercepts, right, my denominators are 2 and 3, right, so which leaves me with the lowest common multiple as 6. So which means when I go into my sketching, right, I'm going to face it in such a way that each box is going to be a pi on 6 unit on the x-axis. So let's start by doing that. So I'm going to mark my 0, so 1, 2, 3, 4, 5, 6 leads me to pi, right, 7, 8, 9, 10, 11, 12, gives me 2 pi, right, you can mark the middle if you want to make it a little bit easier. Right, now we're going to mark our mean value, maximum and minimum, right, we've talked about the maximum being 0.27, so roughly there, so that's going to be minus square root of 3 plus 2, and the minimum value is going to be minus 3.73, so somewhere there, that's going to be minus square root 3 take away 2, and the mean value being 1.73, so roughly somewhere there. Alright, so that's going to be minus square root of 3. Now, like we did the previous example, I'm going to draw some straight lines to make our jobs a little bit easier. Alright, 1, 2, and 3. Right, so I've drawn my graphs, my lines, to make my job a little bit easier. Right, now again, like we did in the previous example, we're going to draw it without the horizontal shift, so which means we're just going to draw the graph of y equals 2 times sine 2x minus the square root of 3. Right, positive sign, which means starting from the middle. Right, so that's half the period, so which means my maximum is going to be in the middle of there. Again, 1.5 units on the x-axis. Similarly, my minimum back to the mean value, maximum, mean value, minimum, and then the mean value, right? So obviously if I connect that with my graph, right, that gives me the graph of the sine function without the horizontal shift, right? So obviously in this particular question, our horizontal shift is 2 times sine 2 brackets x minus, I believe it's pi on 3. I'm just going to double check that. Yep. Right, minus pi on 3 units, take away the square root of 3. Right, so pi on 3, if I consider with the denominator of 6, so pi on 3 with the denominator of 6 is same as writing 2 pi on 6, right? It's good to know that because 2 pi on 6 is basically 2 boxes on the x-axis, the way we've scaled the x values in that Cartesian plane. Alright, so we're going to move pi on 3 units to the right, so which means our graph is basically going to start at that particular box there, which is 2 pi on 6 units from the origin, right? So which means we're going to start there, and if I quickly go by the pattern of the graph that we already used, alright, we're 1.5 boxes for each quarter. So if I quickly mark those points, right, I'm going to have right 1.5 boxes and then back to the center. Alright, 1.5 boxes, back to the center, 1.5 boxes, back to the center, right? And then we don't have 1.5 boxes to go because we've stopped at 2 pi, right? Now, if I go ahead and quickly mark my x-intercepts, right? My x-intercepts were in the order pi on 2, 2 pi on 3, 3 pi on 2, and 5 pi on 3, right? So let's just quickly write that down. So pi on 2, 2 pi on 3, then we had 3 pi on 2, and 5 pi on 3. Right, so if you want to make your job a little bit easier, you can write everything with a denominator of 6. So that's basically 3 pi on 6, 4 pi on 6, that one's 9 pi on 6, and then this one's 10 pi on 6, right? So by having them in the same denominator, it makes it really easy for you to plot it on the graph, right? So 3 pi on 6, 3 pi on 6 is going to be the third box on the x-axis. 1, 4 pi on 6, the fourth box, right? 5, 6, 7, 8, 9, so 9 pi on 6, 10 pi on 6, right? So with that, I've sketched my x-intercepts. Now we talk about our endpoints. Endpoints were 0 minus 2 times the square root of 3. Then we had 2 pi and 2 times the square root of 3. So 0 minus 2 times the square root of 3, which we approximated to be 3.46. So 1, 2, 3, so 3.46 is roughly going to be there. Right, and then similarly on the other side, 3.46 is going to be roughly over there. Right, now there's one more thing we need to think about, right? So I'm just going to join the graph for the moment, and then we'll talk about the last bit, which is critical. Right. Right, now the last bit, which is critical, I'm just going to erase this bit, so just bear with me. You'll understand why. Right, so I've joined this part of the graph, right? So we still have to do the starting bit and the end bit, right? Now we talked about each quarter being a distance of 1.5 boxes, correct? Now from this particular point to get to the y-intercept is still more than 1.5 boxes, which means I'm going to have another minimum in this particular case, which means I'm going to have a minimum at that particular value, which means if I have to complete this part of the graph, I'm going to go through the minimum before I come back to my endpoint. Right? On the right hand side, we're only traveling one box, which means our minimum is going to be over there, which is outside the domain range that we're trying to sketch. Alright, so which means we don't have to worry about it. We're just going to straight away jump to that value and not worry about the minimum, which is outside the domain of what we're trying to sketch. Alright, so that concludes the conclusion of our lesson. Right, I hope sketching horizontal translations have gotten a bit easy for you. Like I said, attention to detail is really important for getting horizontal translation right. Right. Thank you for watching, and have a lovely